Hi, I'm Papa John, and I built this go-kart from scratch, do-it-yourself project here at home for me and the grandkids. It's an electric go-kart with a 800-watt DC motor. Takes about 30 amps. The wheels are 10-inch wheels from Harbor Freight. The control system is a small pulse width modulated power supply made for a 36 volt motor with an 800 watt version. So it current limits at 30 amps. If you don't have some kind of current limiting, I discovered that you can burn out motors. I've had some electrical background, and so I thought I could do this go-kart with my own control system. And originally I had switchable resistor arrays that I could take out of a loop going between the battery and the motor, thus providing more current to the motor. But when you get to the last connection and you get rid of the resistance, the motor wants to take 50 amps or more, and it's really only designed to take 30. So a 36 volt DC motor wants to burn itself out. If you have little kids who are jittery on the accelerator pedal, the current will jump up and down between 50 amps and nothing, and in a short time the motor will overheat from the higher current averaged out. If you just get it on the road, however, and speed it up starting at 50 amps, the current backs down to less than 30 amps, but still right on the edge of the full power and full heating. It's still risky to do it without a special controller, and this controller is easily available on the internet. I use 6 12-volt batteries, 2 in parallel for each stage of the 12 volts segments that I put in series, giving me 36 volts with twice the current of one battery, basically. And I did that so I'd have longer running time on the go-kart and be more economical on current use, so perhaps the individual battery expenditure would be less than half of what it would be if it was driving by itself. The controller is connected to a twist grip velocity control pedal, which I rigged up with a grabbing device to make a foot pedal out of it. Then I have bars I can put on and change the angle of to speed limit my grandkids, to keep them at speeds that they're comfortable at. The brake is a simple little drum brake back here, showing under that cage there, and the shoes for that are fixed with respect to the chassis while the drum rotates with a live axle. I've covered it and the motor section because of the moving parts that you don't want little fingers to get tied up in, as a safety thing. I taught myself how to weld to make the chassis and used 1/4 inch steel bar by 1 1/4 inch width at various lengths, bending and cutting them here. I'll show you my bench inside the garage. I basically bought a nice workbench with drawers and covered it with a big piece of fiberglass covering cloth, like a blanket, since fiberglass doesn't burn, and then covered it with a sheet of stainless steel. And the reason you do that and then do your welding on this bench is that there's a lot of splatter when you weld, and the splatter will stick to regular steel, but it's easier to scrape off of stainless steel. It doesn't stick well. So the stainless steel bench gives you a substrate that you can clean up after each use, and you can also use it as a ground, because the basic idea in this welding is that you have a 25 volt supply at 90 amps feeding this tip here of the welder, which is driven by a motor to feed the welding wire with the internal flux out at a variable rate that you set on the main control. When you feed it out at 25 volts, the ground system is basically this clamp, which you clamp to your work that you're welding on. And if you're going to have something welded to the bench, you can clamp to the bench and use that to carry the current of the welder. But you can also clamp to some part near the point where you're welding, and it works great. So what you're doing when you weld is you're essentially running a high current through a thin wire back to the ground and back into the welder. And it creates it basically is like a controlled short circuit. You're basically short circuiting, running a very high current in a very small area where this wire is being fed. So you create a great heat, melts the wire, heats up the metal to a point where the wire with the metal will all fuse together. And that's what this kind of welding is about. And you can go on the internet and get on YouTube and find, homemade instructions for running your welder equipment if you want. A grinder is really handy to clean up this is an edge grinder. It's like a $15 tool. Is really handy to clean up your weld joints afterwards. And then I have the rest of my garage here set up for woodwork. And I used to be a jeweler, so I've got the acetylene oxygen equipment and a burnout equipment over here, an electric kiln. I can use the acetylene oxygen for heating up metal and then pounding on it and bending it, making it more supple when you heat up the metal to red hot. Then I can heat up the metal and put it on this anvil here and pound on it. Another thing that's you learn the skill of is creative clamping. You're holding something together at weird angles, a variety of clamps, C-clamps and vices and so on, to hold the stuff together so you can make these welds. Well, let's go for a ride. This is designed to go like 18 miles an hour. It has a 5-to-1 reduction from 11 teeth to 55 teeth going to the wheel. We turn the switch on, and now I think I have this set so it will current limit at my 7-year-old grandson's speed. I figure about 7 miles an hour or so is enough for him. And I figure I can put it at about 4 miles an hour for my 5-year-old grandson. I used to have it set up so that I could do it reverse. You can see from the meters here, the current meter shows 20 amps being used, and I have voltage indicators for the 3 sets of 12-volt batteries. I used to have a forward and reverse control, but it won't work with this type of controller. It worked with my resistive controller. Yeah, this is Papa John again, back in my little electric go-kart for me and the grandkids. And I took off the bar that blocks the forward progress of the accelerator pedal so that I can now get full speed. I'm going to turn it on over here and push the pedal and send us down the road. This time I'm going to go in the street, so I'll get up a little bit of speed. It takes the full 30 amps while accelerating. But as it comes up to speed, the current comes back to about 20 amps. So I'm a 210 pound guy on a 120 pound go-kart with an 800 watt DC motor, probably going about 15 miles an hour right now. I don't have any rear view mirror, so I have to kind of like turn around and look. Looks like I'm okay. So again, the current comes up when you're accelerating. Okay, I'll wait for this guy over here. We live in has a 60-foot frontage, and so you can count how long it takes to go from one edge to the other. And I did that. Let's do it again. Here we are, 1001, 1002, a little over 2 seconds. Yeah, if it was 2 seconds, that'd be about 21 miles an hour. But it's a little under that. So it is running pretty much at a full speed. Figures out around 17 to 18 miles an hour. And I should be able to run it at full speed for an hour and a half or something, to deplete the 18 amp hour batteries. Well, that concludes the little test drive. Put my foot on the brake, power off.